One of the first things communication men learned in this war was that an improved way of laying field wire was necessary. The equipment used did a pretty good job, but more speed was required. And more important, there was a definite need for laying field wire without special equipment. This was especially true for assault wire. Real unit RL-39 was inadequate in other ways. It was too noisy, often revealing our presence to the enemy. Also, a man had a tough time handling his weapon and the RL-39 at the same time. To lick these problems, the Signal Corps began laboratory experiments. It was soon found necessary to depart completely from the conventional reel. A coil was needed which would pay out from the inside. A ball was found to be unsatisfactory because the outer layers collapsed. From one coil, the wire paid out with an undesirable twist. From another, it paid out straight, but too easily. Finally, a coil was developed which solved all these problems. The successive layers neither tangle nor collapse as the wire pays out. The wire comes out straight and freely, but not too easily. This new coil allows a man complete freedom of action. At the same time, it enables him to keep in constant communication with the rear over the very wire he is laying. It is also practically silent. By pre-splicing the standing end of one coil to the payout end of another, a number of coils can be laid continuously. Coils used this way must be accurately aligned. Here, this is being done by lashing them to a wooden trough with the aid of D-rings on the covers. With ordinary field splicers and without special equipment, these coils permit laying wire as fast as 60 miles an hour. Communication can still be maintained under these conditions. Thus, this coil gives wire communication almost the mobility of radio. To understand how these new high-speed coils are built, let's take a look at the machine which has been developed to turn them out and see how it works. The process begins with the coil form, which is made out of 2 plywood discs and a cardboard core mounted temporarily on a steel mandrel. The discs are fastened in position with wood screws to hold the form absolutely rigid. The coil form is now ready for the wire. This liquid being poured into the container is an adhesive. It goes onto the wire to prevent it from paying out too easily while it is being laid. The machine was built to accommodate a DR4. All supply wire must be on such a reel, which holds 2 miles of assault wire, enough to wind several high-speed coils. Now, the supply wire is mounted on trunnions and locked in place. The wire is strung through a series of guides to keep it from tangling. An idler pulley keeps the wire at the correct tension as the coil is being wound. The wire passes across the top of a grooved wheel which dips into the adhesive and applies it to the wire. Rollers guide the wire onto the coil. The end is pushed through a notch in the cardboard core so that it can be taped to the mandrel and held fast. The coil can now be wound. The mounting of the supply reel makes 1 turn for every turn of the coil. This pre-twists the wire so that when it is laid, it will pay out straight. The guide is set to space the wire slightly. This makes a more compact coil. When the coil is completely wound, it is rotated slowly so that a layer of masking tape can be applied. This holds the outside layer of wire in place. A layer of cardboard goes over the masking tape to reinforce it. The adhesive being put on the cardboard to hold it firmly to the tape is the same as that which goes on the wire as the coil is wound. Since the adhesive doesn't set immediately, several pieces of tape must be put over the cardboard to hold it in place. A second layer of cardboard then goes on, followed by a special sheet metal cover, which is nailed to the plywood ends. This cover helps make the coil perfectly rigid and also carries D-rings for lashing the coil to a support. The coil is now complete and the temporary supports can be removed. First, the mandrel, then the cardboard core. Before the coil is shipped, metal end plates are bolted in, and the two ends are identified by stenciling. This is how it looks when it arrives in the field, a high-speed coil holding 3/4 of a mile of assault wire. If one of these winding machines isn't available, a high-speed coil can be made on improvised equipment. For example, a thread-cutting lathe can be used. A rope drive connects it to a payout arrangement which is made from a DR5 reel mounted on an RL31 reel unit. A DR8 is used as a form for the improvised coil. A notch is cut in it so that the standing end of the coil can be pushed to the inside. A cardboard core and two plywood ends are used exactly as on the GI coil. The reel is clamped together with long bolts to make the form rigid. The center of the reel has been cut to fit a square axle. The axle used is that of an RL31 reel unit. It holds the coil during the winding operation. The RL31 is driven by the lathe by means of an improvised belt drive. A pulley made from the ends of a DR5 and placed on the other end of the axle drives the payout arrangement. The board just below the payout reel acts as a brake and prevents the reel from overspinning as it feeds the wire to the coil. A piece of tubing mounted on the slide rest of the lathe guides the wire onto the coil properly. Because in this case the payout reel is so far away, the operator pre-twists the first few feet of wire, approximately 1 twist to the foot. As soon as the wire is snubbed to the form, winding can begin. Notice how the wire is spaced. Also, the double wheel arrangement for applying the adhesive. And here's something to remember. It's important not to get either too much or too little adhesive on the wire. The payout reel twists the wire in the direction of its natural lay. When winding is completed, the standing end of the wire is shoved through a slot to the center of the coil. Bringing the standing end of the wire to the center this way makes it possible to pre-splice coils for continuous laying. With this particular coil, strips of cardboard were placed under the masking tape. These were later found to be unnecessary. Almost any type of adhesive may be used on the wire and on the layers of tape and cardboard. Here, rubber cement is being used. Moisture and fungi proofing compound is an excellent adhesive. After the layers of cardboard and masking tape are applied and a protective cover of sheet metal put on, the coil form can be removed. Signal Corps Technical Information Letter number 33 gives a detailed story on the making of such improvised coils. Here's the finished coil ready for use, the standing end and the payout end. Experiments have revealed that the high-speed coil has an amazing flexibility. With it, wire can be laid rapidly and easily in many new ways. By dog, carrying a special quarter-mile coil. By rocket, which picks up the wire as it leaves the launcher. By rifle grenade, to which the wire is attached before discharging. Even by plane. Here a series of pre-spliced coils of assault wire have been placed in a special container. The pilot releases a weighted parachute which pulls the wire out of the coils. There it goes at 130 miles an hour. Development is now taking place with W110 wire and even higher laying speeds. One thing is certain. The use of high-speed coils for laying all types of wire opens hitherto undreamed of possibilities for wire communication.